Double checking the stream. Live. We are live. Not that it matters, but just in case it does. How's it going? It's going. Is it one of those days for everybody else too? Nice. I've got nothing to complain about, although I will complain. I can still complain. So, last week, spring break. Have a good spring break? Spring break, Kansas. That was me. Woo! All right. Yeah. Yeah. Sort of reminds me, Lisa and I once took a Midwestern vacation. Did you know Iowa has a swim-up bar? The Adventureland Hotel, that's right. We spent like 3 days in Adventureland in the Des Moines area. And then that's right. And then we went up to Minneapolis. Anyway, we did Iowa. Pizza Now, that's what I remember. There was a sign, you know, the gas stations on the side of the road, like they sort of put a sign up and then maintenance doesn't happen and whatnot. There was a sign that said like pizza, and there was like everything else was torn off, and it was like now. So pizza now, yeah. Anyway, what do you remember from 2 weeks ago? This class is getting smaller and smaller. That means it must be going pretty terribly, huh? So what can I do to make it better for you?
If you
What do you remember?
That you're better at driving things and doing code on the block.
Not really a strength.
Ask my kids. I was it yesterday. I can't do math in front of them, but I can code.
There you go. Well, this class may have turned into something that's a hot pile of whatever, but I promise you, next class, if you want to take my class in fall, it's going to be amazing. There'll be slides again. There won't be all this markdown stuff. We probably won't go on Git. And just a reminder, it won't be online. So you have to be there to audit it. So that's the main thing that I want to warn you about. Let's see. So you don't remember anything apart from deriving?
We were doing CFA.
CFA still, but it is a psychometric method, a model. Inverse Wishart. Does anyone remember inverse Wishart?
Inverse Wishart, which is Wishart.
That's right. The inverse of the inverse Wishart is just Wishart. What else? We got to a certain point, and we're about to get into multidimensional factor analysis, and somebody had to derail the class. But no, I'm just kidding.
I'm sure I want to talk about.
There's no token anyone here. We welcome all cultures and embrace them, except for mine. Suburban West Coast, Central Californian, not the best culture out there. But it happens. Actually, no, you know what? I'm still proud of where I come from. So that doesn't make it any better or worse than anybody else's. Okay, so let's go back. CFA, we had this example that had people with conspiracy data, which I thought was kind of funny. The Denver airport, we talked about that like 3 weeks ago. Are any of you part of the Illuminati?
We won't fall for that, man.
You're not anymore?
We were trained not to.
Illuma what? Okay, well, let's get back into what we did. Let's go through CFA as a refresher. I will note that this is the last week of CFA, I promise. I'll also note next week we are not having class. Many of you may be gone. This guy's going to be gone, so forget it. But when we get back, we're going to start IRT, I believe. that means I'm officially assigning homework today. I have not changed the homework file before. I've been working on it, and it won't be due until the 12th of April, which is 2 weeks from today. Okay? It says it on the top of the file. If you go to the GitHub repo, you'll see April 12th, 2 weeks from now, which is good. You still have your 2 weeks to work on it. Basically, it's find an article for CFA and do 2 CFA analyses. One that's 3-dimensional and one that's the saturated model. Maybe 1-dimensional. I'll look it up here. I'll come to that when we're done with the CFA lecture. We'll talk about it at the end of class. The main thing though is there's no derivation this time. I know that was a pain for a lot of you last time. No derivation, and most of the syntax. In fact, everything you need to do the analysis is in this syntax already, including the wisher, which is where we left off before. So let's go through just a quick. Do you have any questions for me before we start? Okay. Let's go quickly through all of this. I need to read in data. That would help. Read in our conspiracy data. Remember that where we started with CFA was a 1-factor model, and we had a standardized factor, meaning we had factor variance was 1, factor mean was 0. We estimated every loading, unique variance, and item intercept. Did I say that right, Lisa? Item intercept. However, I'm not going to run that for you. Things blew up. Remember that? It was bad. We're like, WTF? This is CFA. It shouldn't be that hard. Right? Do you remember why they blew up? Maybe you want to share with me?
-1 times -1 is 1.
That's right. There's multiple modes in psychometric models, and most of the time you don't think about them, particularly in likelihood-based settings, because the likelihood function is built to creep toward one mode at a time, and if you start it on one side, it moves in that direction. The multiple modes are equivalent, though, so it just happens. Things that you never think about in a regular class just show up sometimes in Bayes. Next, then we move down to fixing this by identifying it with, or actually by setting a marker item. And by setting a marker item, and this is where I screwed up the code because I tried to put in, this is where I put in some of the stuff for reliability. We don't want that yet. When we set the marker item, we set the first item's factor loading to 1. Arbitrarily pick the first item, although it shouldn't matter. We estimated the factor variance, and that did the trick because that one item moving in the positive direction avoided everything being all positive or everything being all negative. And that's only because in my data, I know or in these data, most of those factor loadings are all going to be mostly positive anyway. If one, it could be possible that one of them is negative. If we had set the one that was negative to the marker item, it would have gone the opposite direction. So all sorts of weirdness going on. This worked. But did it fit? No, it did not fit, which is really frustrating, right? Because you spend all this time doing what should be a relatively routine and simple analysis, and it said, oh no. So the convergence happened, but model fit didn't happen. And the way that we ended up finding model fit was by, so here's convergence. Let me just get there. Convergence. I have all the factor scores put into the analysis now. Here's my summary. You can see all the parameters. They're kind of the posterior mean and standard deviation here. It's each person's factor score. There we go. Factor variance is 0.48. Yada, yada, yada. So moving on, we did a posterior predictive check. We said to check model fit. And we did this by taking, let's walk through the steps of posterior predictive check again. Posterior predictive check, we randomly draw an iteration from the posterior distribution that we have, and then use that iteration to be like the population parameters and generate data. And then from that data you generated, do some type of summary statistic. Right, and I'm saying some type of because there's not a really uniform agreed upon summary statistic that we should be using. Here we did the covariance, we did the standardized root mean squared residual. we did the RMSEA, the error of approximation. And what we end up seeing is when it does not look nice, right? That's standardized root mean squared residual looked good, but the RMSEA was pretty terrible. And then if we looked at some of the correlations we had, like here's an example item. This is a correlation between items 1 and 2. That red line is what the ML estimate of the correlation data happened to be. And this distribution is our posterior predictive correlation. So it's at the tail of the distribution. And we would say, oh, that's some misfit. Unfortunately, there's no easy way to say what misfit is, like how much is too much. We don't have that standard yet. Maybe we do. Maybe someone needs to come up with that. Maybe someone can think about that, but that's not me right now. But here are the list of correlations that didn't fit. And when I say didn't fit, I just arbitrarily decided to say in the upper or lower 2.5 percentage points of the posterior predictive check distribution. Right? And you'll see some of them, wherever you see a 1, that means no simulated correlation was ever higher than the true value. Whenever you see a 0, that means no simulated correlation was ever lower than the true value. So it's telling you a little bit about model fit as you go through. All this been nice, remembering? We then took a little bit of a side path, and I said, well, but we could also do the same type of work if we did a, of course, I didn't install, oh, that's going to take a while. There it goes, I think it's working. Some of these packages took like an hour to install, and I had to, because the tidyverse and our oxygen 2 depends on XML2, but XML2 with a certain configuration, I had to uninstall R and then reinstall it. So I use a Mac and I use a command line homebrew to install it, and I installed XML2. Should be there. Couldn't find it. Couldn't figure out how to set the right path for it, so I just said, screw it. I'm going to keep moving on. So I have to reinstall all of my R packages. Anyway, frustrating. Just should have used SAS, right?
You get what you pay for.
So, what we end up doing here to make this, to compare, we actually wanted to compare in this CFA model, the saturated model, with the model that we have. So this is the basis for some model fit statistics, one being RMSEA, another being the likelihood ratio test, although when we get our minimum function fit statistic, if we were doing ML versions of CFA, that minimum function fit statistic would be the likelihood, it's related to the likelihood ratio test. So it's there. Not going to wait for that. I also found, I was trying to show you a way of kind of thinking sideways about this, but the main thing with it was the saturated model is one where we estimate every mean, every variance, and every covariance. And when we got into building this, that's where Wishart came about, right? Because in JAGS, our data follows multivariate normal and then norm, mean, mu, variance or covariance matrix, sigma, inverse. And then remember in JAGS, they always do the inverse rather than the actual covariance matrix. So here, the prior for mu is multivariate normal. We talked about that before. Kind of what our prior is when we did linear model, because this is just a multivariate linear model. It's not really that big. However, the sigma inverse, this is where the covariance matrix follows this Wishart distribution. So the inverse covariance matrix follows a Wishart distribution, or another way of saying that is the covariance matrix follows an inverse Wishart distribution. That is a conjugate prior, which makes it sample very quickly, relatively speaking. The best way forward for this, if I were to run this, I don't want to run this yet. I did posterior predictive checks using kind of the Bayes idea, but let's skip past that for a moment. What we really want to do, though, is we could do a model comparison for model fit between our model and the saturated model. Right? Instead of doing, so this is sort of, saturated model we know is going to fit, should be fit all the time. I didn't go through the process, but we should go If we did, we'd probably see no outliers unless we put a really tight prior on our data, which is probably easy to do with the Wisher because we don't know what we're doing with it most of the time, or at least I don't. But what I'm going to do is I'm going to run both models in R2 JAGs. While I'm using R2 JAGs,